Here we are. Ladies and gentlemen, if the aldol reaction is the most important reaction in organic chemistry, then the second most important reaction in organic chemistry is the Claisen condensation. Yes, chapter 19's got the two most important reactions in all of organic chemistry. So here we go. Claisen condensation. You're starting with an ester, and you guys think you know the pKa, but I might have to help you a little bit. The H is there, and the pKa is not 20. It's higher. It's higher. So if it was an aldehyde or a ketone, then it would be 20. We had to know that from before, and we know that now. So why, when we make it an ester that has a more electronegative O here instead of an H or a C, that would be an aldehyde or a ketone, right? Why didn't that lower the pKa? It raised it. You better be not be using the word inductive in your answer, because that's the one that would have lowered the pKa. There must be something more important going on in the other direction. That's science. It happens a lot. Okay? Got competing effects. And the resonance of an ester should not be underestimated. So it's already resonating. Okay? Think about it. The O's resonate with each other. I'm not going to show it, but the lone pair on here, I'll just show it temporarily, and I'll get rid of it. Here's resonance, okay? That's happening just by the nature of this thing being an ester all the time. Now, you're going to create an anion in the alpha position, and that means the resonance is going to be on the other side. It competes with the resonance I just showed. That's bad. If it's resonating in that direction to the left, it can't be resonating also at the same time to the right. So you're losing a resonance you had to start with. That's a negative effect. You're killing it. We don't like that. So that's why the pKa went up. It's going to be a lot less acidic. And Le Chatelier is going to be even more in our favor than before. When I asked you, why did it look like this was a bad equilibrium, it actually ended up being a good equilibrium. There's my equilibrium error. No, it's backwards, isn't it? It's backwards. Think it'll let me flip it? No. Yes, it will. There. That's better. Oh, I have two arrows going the same way. That's why I did it wrong. I'm sorry. No, you don't have to use two colors. No, we're only doing one step here. Later, we might have two colors. Later, but not at this time. Okay, so here we are. I'm just going to go CO2CH3 for a short form. There's your anion. There's one of these. For how many unreacted esters? What's the difference between, well, we made methanol. And I know you think the pK is 17 or 18, but it's really 16. So 25 goes to 16 is a difference of 11, right? That's is it 9? Yeah. 25, 16, 9. Yeah, 9. So it's there's a billion of these, 10 to the 9th of these, 10 to the 9th, 10 to the 9th of those for every one of those. Guess what your anion is surrounded by? There's a billion of them. Let's react one of those, shall we? And remove this thing from the equilibrium. There's a one-way street. So take your unreacted ester here. I think we're going to go with two colors pretty soon. Red first. Just put it right here. And it's going to hit the carbonyl. Pi resonates. Second step, take a guess. Take a guess. You're going to have a lone pair and there's a leaving group, it gets kicked off with a different color. Purple's cool. Carbonyl's back. And this is the point where a lot of students think they're done, because they go ahead and start drawing it, and they realize that they're drawing the thing that's already on the page. They're drawing the thing that's already on the page to the right. Here's your new bond. Oh, hi. Here's your carbonyl. That molecule's already drawn right here. Why do I have to do this? It's drawn already. I'm done. You're not done. Sorry. You've created a molecule that has an H, alpha to 2 carbonyls. This is not the first time we've asked about the pKa of this. What is the pKa? Because that's this H right here. 10. When you are alpha to 2 carbonyls, your pKa is 10. That's a new one. What's the other product of this acid-base reaction? I didn't show it. I need it. Sorry, of this, it's not acid-base. The other product of this reaction with these arrows. I didn't show what happened over here, did I? Yeah, CH3O minus. That's the conjugate base of methanol. And if there's an acid with a pKa of 10, it must react. There's no if, or sorry, there's no maybe. It's 100% must react to make the anion indicated above. The anion that has a lone pair. Bless you. And a minus charge. I think the last part's the easiest part, isn't it? What's going on in the last part? We're putting the H back on. And there is your Claisen condensation product, which is a beta keto ester. If this is the ester, then this is alpha, and this is beta. There's a ketone on the beta position. So when you see beta keto esters, you should be thinking about Claisen condensation that are used to make these esters. Good stuff. Alpha, beta. Oh, yeah. Okay. Nice. So, what's going on in that one? Want to do some numbering? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So what happened to carbon 2? Two things had to happen to carbon 2. Talk to me. What two things happened to carbon 2? Became an anion by losing an H. Yep. So that's going to be something we have to deal with immediately. And what was the other thing that happened? It made a bond to another number, didn't it? 2 ended up bonded to 6, and the leaving group left. Hey, that's what happened in our first mechanism, isn't it? You attack the carbonyl, electrons go up to the O, come back and kick off the leaving group. Isn't that the whole theme of chapter 18? The whole chapter. Attack a carbonyl, electrons go up. They come back and kick off something. There you go. Esters are a derivative of a carboxylic acid. Chapter 18. I think we're ready to go. I don't think you can get 2 steps in one here. I've seen students try, but they always end up with an OV notice on their test. They'll put the lone pair on carbon 2. They will, pretending it was there all along, and they will get marked -1 OV. Don't try to combine this with the next step, is what I'm trying to say. We can do it with oxygens because they already had lone pairs, right? Yeah, this lone pair on the oxygen is where are the combined steps? Yeah, there was already a lone pair. Yeah, in this case, I produced a lone pair and I used an already one. Here, I don't have one to use from before. I'm going on about something that's not that important. EtO2C goes to C minus, goes to C number 3, hello, 3, 4, 5, 6. 6 is a carbonyl. You don't have to loop it around like this if you don't want to. You do the mechanism across the chain, I don't care. And you've already made the comment read first on your exam, and I'm very lenient. It just has to be on one page of your exam. I had a student in this very room put it on the front page of the exam. That was great. Now, when I do it, I don't take any chance. I want you, because I'll have students, look, you didn't think which color was first. They'll come to me, they will. It's happened, okay? And I do it on every page, okay? But you don't have to, because your time is more critical, right? So somewhere on your exam, red first, some other color second. So I don't have to do that again. It's already on there. Coming down here with a lone pair, attack the carbonyl. Got to put a lone pair on that carbonyl so electrons can come back and kick off our LG, our leaving group. And some of you think you're done because you're going to draw the product that's already on the screen. You're going to lose 3 points. EtO carbonyl and the red bond to the carbonyl and 4, 5. There you go. But don't forget, there's this guy here, and there's also this guy here. You got a strong base and a pKa of, what's the number again? 10. And there's a hint there. The hint won't be on your test. I'm sorry. Remember, you must create the anion before you create the Claisen condensation product. That's the last time you're going to see that remember. You won't be asked to remember again. You'll just have to remember. There's your anion. Now, the only time you use HCl is at the very end. Don't use it when you think it's convenient, people. Okay? Because if you use it when you think it's convenient and there's strong base still around, you've created a nightmare for me to grade. Okay, so now you've made this product, the reaction's over. You're adding HCl. And here's the HCl in step 2. And you've made your Claisen condensation product, which is a beta keto ester. I can even write it again. Beta keto ester. There you have it.